After studying this chapter, you will be able to define sensible and latent heat, describe 5 changes of state, explain superheat and subcooling, use the 5 refrigeration applications, define saturation point, and explain Fahrenheit and Celsius thermometers. Sensible heat causes a change of temperature, but no change of state. If heat is added and the temperature rises, it is sensible heat. Likewise, if heat is removed and the temperature changes, it is sensible heat. Latent heat causes a change of state, but no temperature change. During a change of state, the temperature remains constant until the change of state is completed. As shown, when ice is melting to water, the temperature remains at 32 degrees until the last bit of ice melts. Adding or removing heat from a substance changes either temperature or physical state. Because ice, water, and steam are familiar to everyone, it is used here to illustrate the principles of sensible and latent heat. Water is not used as a refrigerant because of its high boiling point. The boiling points of refrigerants are often well below zero, but the same principles apply. We have learned that heat must be added or removed to cause a change of state. 4 terms are used to describe the different changes of state. For the latent heat of freezing, heat is removed to change a liquid to a solid. For the latent heat of melting, heat is added to change a solid to a liquid. For the latent heat of vaporization, heat is added to change a liquid to a gas or vapor. For the latent heat of condensation, heat is removed to change a vapor to a liquid. The melting or freezing point of a substance always occurs at the same temperature, but the temperature is different for each substance. Water, for example, always freezes at 32 degrees, and ammonia always freezes at minus 107. The same amount of heat energy is involved in a change of state, whether heat is being added or removed. The same amount of BTUs are required to freeze 1 pound of water as it does to melt 1 pound of ice. This is true of all substances. The boiling or condensing point of a substance always occurs at the same temperature. Exactly the same amount of heat energy is involved, regardless of whether heat is being added or removed. It requires the same amount of heat energy to boil 1 pound of water as it does to condense 1 pound of steam. This is true of all substances. Latent heat of evaporation is where the action is, and high numbers are best. A good refrigerant should have a low boiling condensing point and high latent heat values, or BTUs per pound. Water would be an excellent refrigerant because it has the high numbers, but it also boils at 212 degrees, which is not good. Ammonia is a much better refrigerant because it has the high BTUs per pound and boils at 28 below zero. However, ammonia can be dangerous. Therefore, we choose refrigerants that are safe, low boiling points, and not quite so high numbers. The latent heat of sublimation describes a process where a solid bypasses the liquid state and changes directly to a vapor. Dry ice or frozen carbon dioxide is a good example of sublimation. Let's stop here and take a quick quiz, just to make sure we have our thinking cap on straight. Determine the word that describes the change of state taking place. Think about each question, then click on the answer button to see if you're correct. If your answer isn't right, review that area again. Saturation point means boiling or condensing point. This refers to the temperature-pressure relationship where a change of state can occur. Any temperature above the saturation point of a substance is called superheat. Superheated means sensible heat was added after the substance became a gas. The steam shown here has been superheated 5 degrees Fahrenheit to a temperature of 217 degrees. Our atmosphere is composed of superheated gases because their boiling points are well below zero in atmospheric pressure. When the temperature of a substance is below its saturation point, it is called subcooled. Water is shown here at 100 degrees Fahrenheit, which is 112 degrees below its boiling point. A refrigerant with a saturation point of minus 40 degrees is 10 degrees subcooled at minus 50. It has to warm up before it can boil. Saturated condition is a term that refers to the boiling or condensing point of a substance. If a substance is able to change its state, the condition is called the saturation point or boiling point. Superheat describes a gas has been heated to a temperature above its saturation point. Subcooled refers to a substance having a temperature below its saturation point. Temperature does not reveal the quantity of heat in a substance. It merely indicates the heat intensity, or how hot a substance is. Temperature specifies how hot a substance is, but does not indicate how many BTUs are needed to reach that temperature. To reach the same temperature, the 5-gallon container of water on the right requires 5 times more BTUs of heat than the smaller container of water on the left. The Fahrenheit temperature scale places the zero where a saltwater mixture freezes, and has 180 divisions between the freezing and boiling points of ordinary water. Temperatures that occur below zero are expressed as a negative or minus. For example, a temperature of 10 degrees below zero is written minus 10 degree F for Fahrenheit. The Celsius temperature scale has 100 divisions between the freezing and boiling points of water. Scientists have established that heat is always present until absolute zero is reached. This is the lowest possible temperature because all heat has been removed. At absolute zero, all molecular motion stops because there is no heat in the substance. Absolute zero on the Fahrenheit scale is minus 460 degrees Fahrenheit, and on the Celsius scale it is minus 273 degrees Celsius. Cryogenic systems are capable of producing temperatures from minus 250 Fahrenheit to absolute zero. Such temperatures are primarily used in laboratories to perform scientific experiments. For example, at absolute zero, all substances, even rubber, become perfect conductors of electricity. Research in the cryogenic range has resulted in the discovery of materials that are superconducting at temperatures well above absolute zero. There is no universal do-it-all refrigerant or system. This chart shows 5 different applications, which are terms commonly used in this industry. Each application automatically describes the type of system. For example, when speaking about comfort cooling, refrigerant 22 would automatically be assumed. A low temperature application automatically becomes a freezer, and certain refrigerants and equipment are used. The word ambient refers to the atmospheric conditions surrounding an object, especially the temperature. Outdoor air temperatures, or ambient, greatly influence the operation of all air-cooled systems. Carefully read the question and determine your answer. Click on the answer button to see if you are correct. If you are wrong, move your mouse pointer over the underlined sentence until the pointer turns into a hand. Use the hand to click on the sentence, and the program automatically takes you to the proper page for review. When finished with the review, use the hand to click on the underlined sentence and you will automatically return to the test page.